Okay, I think I can start right now. I hope your practice is going on. Did you guys execute all the advanced queries, whatever I confirmed yesterday? Are any questions out of it? Okay, let me start the session. Yeah, today I'm going to explain one more new topic called uh, SQL joins, which is very important topic today. Okay, this is most important topic in SQL for SQL, all the SQL developers who are working on it. So they need to understand about the relationships. Okay, and how to get the data from uh, you know uh, one table to another table, or we can join the data in a query. So here today I'm going to discuss about the joins. When I say we do have a multiple tables that are having relationships, and how to get the data in different way. So that is a overview of all type of joins and real time employee and department table examples, and the detailed syntax and use cases that I have prepared here, and I gave some practice questions also for you two guys to practice it. There is a SQL joins. Now today we see the name suggests join is to use or to join or combine the data, okay, from more than two tables. We can apply on the same table itself. It's kind of a self join is a different one, but the most probably the joins where we can get the data from, or join the data, or club the data from more than two tables and display it. Because when we are talking about the relational RDBMS, relational database management system, right? We do have a multiple database with relations, employee, employee table and department table, right? Employees are having, some same departments. So one department having like multiple employees, okay, but one employee having only one department. So if we say that the relationship between employees and department to employees are one to many, and employee to departments are many to one. Many employees are mapping to one department, and one department having many employees. So we can say like one to many or many to one. So here when I say like when we're talking about joins, right, to can match different data with in various ways. So mainly that we can talk about, if we say joins here, these are follow: inner join, left join, right join, full join, and cross join. Okay, the mostly we use like kind of inner join majority of the times to match the rows from the both the tables. This is most frequently commonly using query join type. Some of the cases like based on thing like in a left join we use it. Okay, so what are matching? Okay, if you take two tables, Okay, now just if you take like two tables here, okay, this is like an employee we can, okay, this is the department I can say. Now just I'm going to draw a few columns here. Okay, this is a department and employees. So employees table we do have it. So let me also take the employee. Sorry. Okay, just a column like it's ID here. I'll keep it. Uh, Name. Um, so I put department ID here. Okay, and here also this is department ID. This is department name. That's fine. This column is not required for now. We'll keep it. So if you see that employees here, um, you see employee ID 1. Okay, name, let's say Rama. Okay, departments I'll take like two departments like in employees wise. Department ID is 1 and sorry, name is like IT, and department 2 is, sorry, 2, the HR 3, um, admin. Okay, three things now. Now you see one drama and two Raghu. Rama is from IT department. So when I say IT department, so we no need to add entire details of this, right? Like we can map it here. What is IT department ID here? 1. Okay. So Raghu is also from IT department, right? Then can say 1. So third employee, okay, Raj. So here I can map Raj is HR 4 are now. Okay, then I'm mapping 3. You see it here, 4 employees are here. We have department. When I say okay, what I do is now I'll no I'll give um, let me erase it. I'll give the same one one department. I'll keep it admin no employee for now to for safe of let me erase it. Okay. 1. Okay. So there are 3 the 4 employees, 3 are let to IT department, one is HR. So Raj is HR department, remaining all are IT department, assume. Okay, so this is the mapping that I have taken between these two tables. Why you require two tables here? So if we map it one ID, that ID is mapping to the particular department table. So we no need to maintain all other information. If you want to get that some department name and department some other details, complete details, we can keep it in the department table. If you hold the this ID in this table, that is linked to this, right? The same as how we are getting you know ID proof as Aadhaar for every company or while joining, or it's they are mandating, right? So ID proof is Aadhaar. So they don't require all the information, they require only Aadhaar number. Okay, if you want to know the financial information, for that they'll ask you just PAN number. They don't ask you other all other details, because the PAN is having the all the information, right? They'll map that PAN ID and their table, that's all. The same way, now department is also having ID in this mapping the employee table. So whatever the details of the department, we can get it by querying it here. Okay, so the queries are different ways, as we mentioned, like inner query. So inner query, what we are talking about here right now, we can talk one after another. Inner join returns only matching rows from both the tables. Okay, for example, if you want to get the employee ID, name and department name, right? So then the output should be, for me result is 1. Okay, so it should be like result should be 1, and name should be Rama, and here department name should be IT. Okay, then second one is 2, then Raghu, then okay, third one is one map, right? IT. And third one, if you say 3, Raj, Raj, then HR. Fourth one, 4, and admin. If you see it here, I'm getting the result like this. Okay, whatever the result that we are getting it here, I'm not printing. I'm not getting them because the tables are there, like a static tables with the data already there. Just I'm framing the queries to retrieve the data based on my convenience, based on my requirement. So here I want to, because if you give this department ID, for end user will not know, right? So to project it, some report cards or something like, and I want to give the complete details. The backend we are mapping this like an employee table. If you fetch it only for employee, department ID, if you give it, they don't know anything, right? So that's why like I want to print a department ID place. I want to, fetch the associate name of the department and keep it there. So in this way, now you see whatever the mapping or matching the data only shown here. Okay, where the department ID employee dot department ID equals to department dot ID. That's what I'm fetching the query, that inner join. I'm going to join with this table column. Okay, this table. This table. So if the matches department employee, what is the department ID in the employee column, sorry, employee table, and department ID in the department table. So department ID in the employee table equals to ID in the department table. If they both are matches, that will get printed here. That is the inner join. If they matches both, okay, then it get printed. So if it is not matching, it won't print. Okay. So for example, see, sorry, here, not admin. Sorry. So here, sorry, not admin. Arnav is one, IT, right? My bad. I put here strong one. Let me erase it. Because what we map here in the table one, right? One is nothing but IT department, right? One is IT, right? If you see it here, what are the matching that only data got filled here? Arnav, Rama IT, Raghu IT, Raj HR, Arnav IT. But actually, in the department table, 3 is there with admin. The data is not here, right? So that data is not there. So it won't print here. So whatever the records, if you see the records are 4 records are there with that matching, the whatever the matching data that got printed here, this is called like, inner join. So we'll execute and see that as well. But you need to understand is returns only matching rows from the both the tables. Okay. Okay. The example also I gave here, employee ID, name, department ID, and salary. This data is like this, and department is like an HR, IT, sales, and finance. So when we write the inner join, we are joining here 2 tables, right? What are we getting is employee ID, employee name, department name. That's what, because department name is there in the department table. If you see it here. Okay. Employee table having only department ID, not the department name. As I shown this, use case, fetching it only employee, sorry, department name along with the employee details, not the ID. The same way like an employee name. What are we trying to get here in the query? Employee ID, employee name, and department. Only 3 columns we require. Same as like this. From both the tables, because actually department name is not there in the employee table, right? We do have only ID, but we require department name, right? We need to join the other table. What is the other table? Is department table. So this is a department name. here from employees, a department name from employees E, because we need to give the references, because we are calling, we are joining the data together in the same ID. So to avoid that ambiguity, we need to give the references. Okay, which columns are referring, because the two tables are may have the same column name. So while executing the query, if you don't give the references, then it will be there will be ambiguity occur, and you may get the wrong result or may get failures. So what are we doing? Like in inner join, we are doing it inner joining and inner joining departments table employees E, inner join department table D, on which column? Because we need to join two common columns, right? Which column are common for both the tables? Department. So here department ID and employee and ID is in department table. So yeah, while creating here department ID is created like a department ID, right? Department table DEPT ID. This was like they put the same column. E dot DEPT underscore ID equal to D dot DEPT ID. So this is the condition. It's clear, right? So while executing, it will try to match it each and everything. First, one, right? One is there or not in this? Yes, one is there. So here also one is there or not? Yes. So these two rows will connect on it. So this entire row is representing as D here, department D, because we are saying like department D, right? Once you identify the row, refer as the D. On D, which column that you want, you can fetch it. If you want D dot ID, you will get the department ID. If you get D dot name, you'll get the IT. Same as like employee E, right? If you identify this one, this that reference pointing to entire row, not the particular column data. On the reference, you can read out whatever you require, right? So with this, now you see it here, one alias in HR here. That's why, like, if you to see the two tables, department ID is 101, here 101 is HR, right? Right. The second one is here 102. 102 is, do we have 102 IT here, right? That's what we got, IT here. Yeah, there is a third one, put null here. We didn't insert anything value department ID for Charlie. We do have a null in this department table? No, right? So that's what we don't see Charlie here, because it's not matching. This is match the exact one and find the result here. And what is the other one here? 103. 103 is nothing but sales. You see, you got the sales here. So one is null entry is here with the Charlie, so that Charlie didn't come, and department table finance is there, but 104 is not mapped to anywhere. That's what we don't see. From left side table Charlie is not there, and right side table finance is not there, because the both are not matching. Could see only 4 records. Sorry, we could see only we could see only 3 records here. Okay, one is one employee ID we are printing, right? 1, 2, 4 table. Clear, right? So we'll try to execute one after another. Okay, and the same thing left join, left outer. You can also join left outer, left join or left outer. I think as name suggests. So if whatever the it will check the combination both and add the whatever leftover leftover rows at the left table. Okay, we'll add here. So when I say the two tables, right, from is like is a left table, join on is the right table. Okay, when I say like here the same thing, only keyword will change. So employee is the left table, left join on departments. So here we mentioned inner join. So instead of inner join, if you mention like left join, right, So it will consider first, it will take the common values for the both the both the table, and add the left side of the table remaining elements from the left side table. That's a left outer. So that's what, like, on the above, Charlie was there. It didn't add in the inner join, because because this is having only is having null value department ID, right? It's not matching. So that's what, like, this only is left over at the left side. So these three all displayed in the first query are inner join table. Charlie only left here, right? So that's what, like, this is this along with the common thing, add the whatever the leftover stuff here. Like Charlie is the leftover, right? The record. That's what, like, in leftover join, if you see, you can see Charlie here now along with this. I hope you got it. The same thing like right outer. Right outer also names are the same way. Okay, which is exactly opposite of left, right? So it will checks it checks the matching data and add the leftover rows of the right table. Same thing in the above, whatever we missed. I think Charlie was there at the left side. That's what I added when you add the left table, but you are joining right here, right? Employees a right join a department, right? So what are the leftover data on the right side, which is finance? Finance is not mapped to any employee in the in the main table, right? That in this table, right? That's what you don't see it here. Okay, this is the right table. And like, and third one is like full outer join. Full outer join or full join, you can say. Yeah, MySQL is not supported, when I say like full join or kind of something like where we can say union. It is same thing, like, it's combined of all. Union of left, join left table and right table. Okay, so left join and right join together is nothing but a full join, meaning like you will get the data, left side data and right side data together, you can display here. Okay. And one more interesting part, you can see the cross join. This one you say, this cross join is nothing but like, all the combinations. So we do say like permutation and combinations, right? So all the stuff like, this Rama with IT, Rama with HR, okay, Rama with admin, Raghu with this. All the combination will fetch it when you make it cross join. So that will really help when you want to generating the reports with all the combinations, right? Then you can use a cross join. Okay, we'll execute that in our MySQL workbench and see. Okay, I mentioned here the use cases also, particular when we need to use join, when you use join, inner join and left join, right join is the purpose also, so that like if you whenever the interview questions, the mostly the last interview questions, right? So then you can answer of your own if you understand the concepts. So my main motto is like, we need to understand the concept and dig into it, and you can frame it of your own. My main motto is like, you need to frame it of your own definition. When you can frame of it your own, if you understand rightly, otherwise you need to remember all the words. So that is the most difficult part. So that's what you understand. If you understand, you don't need to refer any of the books to buy a definition. If you understand the context, then you can frame it of your own. So you can define of your own definition. So I'm not saying like by heart these definitions forever. Yeah, you can practice this also. Now what we can do is like, at least we can execute couple of queries. Before going to couple of queries, like, we'll try to frame this table now. Okay, there are two table, employee table and the department table, right? Just will create this, table. What I can do is now I'm going to uh, SQL workbench. Oh, it is there in the first table, right? Okay, so we do have it. Okay, Maybatch here, and we do have a employees table already. Yeah, I think we do have. We are playing around, right, with this one. We do have ID, name, department, and salary. Okay, what is missing here? Actually, department ID is missing. Okay, we clubbed here department ID here, right? Actually, we will segregate this one. Department, the name will move to the department ID. Instead, we are adding only department ID here. We'll remove the department table. Okay. What we can do is we are with this now. What we can do is department, right? Department. Okay, what I do is alter. So here, right click here and alter table. So you can alter table names and structure, whatever it is. Okay. So whatever I do is like, where as per the name size, like an employee ID, we can give it, right. So we can give it the same way. So that you can execute the queries as well, right. So what I'm doing, like, emp underscore ID. Okay. So this is the one we are seeing it here, right. emp underscore ID, emp underscore name. And what is the department table? DEP underscore ID, DEP underscore name. Here, EMP underscore ID, EMP underscore name. Okay, and salary. Okay. What I do is here, EMP ID here and EMP name. The second one also I'll add EMP name. Okay, this is for your convenience because you can hold that Word document and can save the query so that you can execute easily to match it the same thing. Employee name, and here this one I'll change. DEPT. Um, I'll remove this one anyway. I'll remove this one. If you want to remove here, simply right click here and delete the selected that got deleted. Okay. And now I'm going to add DEPT underscore ID. It's a of type number, right? Int. Okay. Okay. I kept like this and see. Yes, I hope you got the employee name. Sorry, employee ID, employee name, salary, and department ID. Only the 4 columns, right? Yeah, order doesn't matter. Yeah, but these columns are there. Let me see. What I do is apply. So here it got framed now because we are dropping the department table, right? Department column, sorry. And add and change so and so column names also changing here and this so and so. Apply and finished. Okay, let me refresh this table. So it's not Jan Bass, sorry. Where I would, oh, I'm May tables, right? Okay. Why it is going here? Where did I modify? Is it an maybe actually, right? Okay, employees now. Yeah, columns are modified. You see, employee ID, name, salary, and department ID. Okay, perfect. Now I'll create a department table. Okay, how can you do? Create a table. What is the table name that we are suggesting here? Employees and departments, right? Okay, I'll go to the department, the same name that you can easily manage that queries. And here, if you click this one, columnist will come here. First one is like, what is the column name? DEPT DEPT underscore ID. Is integer, you can say primary key. Yeah, because first one should be the primary key, right? Then the second one is department name. Double click DEPT underscore name. Okay, now you can see. Now you can see department name. Then only two, I think two columns data only, right? We are going to discuss now. Department, that's all. So with this, how can we save this? Apply. Come to apply here. Oh, I think department table already there. That's why its name can't be there. Okay, let's see. Someone is created previously, or okay, we'll see if it is there. Departments. Oh, departments already there. All right. Okay, then we can go and check that, like what is the column structure there, whether it's properly there. So I'll try to alter here itself. The same table. Okay, department ID. Okay, okay, we map like name, college ID, blah blah blah, right? Okay, okay. Department. Okay, that is fine. College ID also we can keep it for now. Department ID, DEPT ID, right? That where we are looking for as per the all queries. So what we do is EPT ID, EPT name. Okay, then all right, finish. Now everything is clear. Department table also got created, and we need to see whether data is there or not in this, right? Let me refresh. Count. Sorry, no. Okay. Okay, we already added. This is the data. Okay, we can add like in a few more. Okay, like IT. Um, okay, computer science, machine learning. Okay, these are the stuff. Yeah, we can add some other departments as well. That is still fine. Okay, but data wise, right? We can have the different data. Uh, what you do will add this data so that you will get the same kind of a result there, right? Try to add here. Let me see. Okay. HR. One or two. And IT. IPCOP, IT. Let's see, will this work like this? Let's see. Oh no, it's not coming. Okay, it's fine. 103 sales. Only 3 departments we have, right? Oh, 104 also we have. Okay, fine. Hmm. All right, just update it here, then apply. So I inserted the department data also here, and employees also will see for time being like we already had, right? So let me see the employees table. How is the structure now? He removed the data, right? Okay, employees, and click here. This will get open here. This data. Okay, all department IDs are null. Okay, now what we do is okay. Okay, I'll put like this. See how it goes. All right. All right. No, it's not copying. That's fine. I'll keep it grid. 101 here. Okay. 102 null and 3, right? 102 103. For timing will okay, we just add it like this and apply. So what we did, like we are able to create the tables and fill the data, relevant data, okay, for the both the tables, right? Here employee also having department ID, which is mapping the department ID, that IDs are here, and departments are having the raw data, which is having the actual department details, right? Now we'll execute the queries one after another now, right? Right, inner join, right? Inner join, we can say, just we'll copyright this now as we explain. Um, okay, where we executed this. Okay, it's got executed on, okay, John batch. Okay, what you do is like, this employee is table from where? It's a maybe actually, right? Okay, what you do is like use may batch schema. It's taking the first one because that is also having the table, right? So that's why it get confused now. So when I use this one now, I'll try to execute this one. Now you see, yes, there was confusion because previously it was showing like it got fresh from John, right? As we discussed, right? This is the inner join. Employee is the left side table and right side is the department table. The same way how we framed here. Left side is employee and right side is the department. Checking E dot department ID equal D dot department ID, right? So each table they're switching here. What are the matching one? The matching is like department ID on employee table. First one is like an alias, right? Where we have given 101. 101 is HR, right? So that's what we like. We got the HR ID here because both are matched and the data is mapped like for the both and got filled here. If you want to see that IDs, this we can put the ID details also here. I mean, just for your more understanding how it is matching. For example, comma, the same thing, like I'll try to put like employee department ID. I'll put like employee department ID. Okay, comma, department DEPT ID. Department ID. Okay, employee in employee department ID and department ID. Okay, now execute. Is it here? So employee ID 101 and the both are matched actually in this, and got the data here because we required only this information actually for our understanding added here, but we required only this much, right? So that's why like we see these details here, and this is a common values because this matching here to understand both. Say inner join. Okay, this is for inner join. Okay, now we can what we can say left join. Right, I think you guys can guess it now. Left join. So when you execute this, so we got the data, right? 101 and 102 and 103 3, and all other left side data also you see. No right side table data, other than we have more than 3 departments, right, in right side table, but we are not listing all other not all the other departments, other than what are matching here in this both the tables. 101, 102, 103 is only the matching. That's what you got the 3 from right side, but left side what are not matching all the data, right? If you see 30 plus tables, right, all other also got added. So left, getting it here. The same thing, right join is also simple. You can join, you can guess it now. Now you could see right side column, left side tables columns are null here, but right side data is here. You see it here. Only you could see. Okay, only 1, 2, 4. Only those 4 rows are matched because 1, 2, 3 are matching with the left database. Sorry, left table, but right side all are there, right? So that's what we got the right side data. Okay. Yeah, this is again like left and right. Yeah, full is like complete, like left side stuff and right sides together. Just like union, we are doing it like. Copy it properly. Oh, I got already copied. Okay. Now you see all the combinations you took, like left side data, right side data, all together got matched. Okay. What are the matching and non-matching? It's combined data. So this plus these rows plus that rows together consolidated here. So it's not matching. So where the for what is the department ID right join and left join data together merged here. Okay, left side data and right side data merged here. So it got. Yeah. Now one more last one is the cross join where we want to see the combination, right? So you see that combination how it works. So cross join same like we need to mention the cross join. The all the combinations it will get listed here. So still coming now. For example, see you see that combination, right? Let me make it down, or okay, let me put it up somehow. Okay. Otherwise, what I do, I'll copy this sentence now and see. I'll keep it in Excel. We can export the Excel also. Now you see this combination itself. Now you see the first one, alias, right? Alias is matching with all the departments until this, right? How many columns are here? How many are here? 15. So total 15 departments, right? Alias combination with 15 departments. Okay, starting from finance to, sorry, computer science. 16, not 15. 16, right? Finance to computer science. Next, Bob set from finance to computer science. Next is Charlie. So all the combinations. This is a cross join, right? Say same thing I told right here. The all the combinations. Okay. This one. Okay. Like this. Okay. And okay. This one. Okay. This one. This one. This one like this. Then this one. Like this. And fourth one also, right? So 4 into 3, 12 combinations. The same way you can see it. Now all the combinations, those many records into total 480. Okay. Okay, 16, right? Okay, 16 into 30. 30 rows, right? So rows into 30 into 16. So this way is the cross join, we can say. So this is a real-time use case also I mentioned here, and some of the practical, practice questions also I gave it here. Just you can try this out. First execute and try this out, and share me the result once you get the result. So if you're not getting any results, and if you're not understanding anywhere, if you get stuck something, feel free to reach me out or post the query there, so that we can connect back in the next session and address that issue. I think that's all from my side. Any questions or any clarification that required? Okay, I think like I'm going to share the screen. Sorry, the Word document, and just you can follow that together and execute it. All right. Yeah, let's catch up tomorrow. Take care. Bye bye.